So what I'm going to do is I'm going to press go live, which means people are going to hear me, but they can't hear or see you yet. So I'm just going to do a holding pattern. Hello, everyone. We're nearly there. I'm just doing some tech fixes, everyone. Thanks for your patience. Skype's updated and it's broken, so which isn't a problem for the stream, but Ivana's on the other side, and it would be quite good if she could see the screen too, which is why this is happening. So if you bear with us just a little tick. There we are. You can see that's the proof Ivana is there. I'm going to just get this slide up and then press this button here. There we are. So you can see us. Hello, everyone. Yes, you can see and you can hear me as well. In fact, you can hear Ivana too. And in fact, you can see her. It's just that we're trying to fix the tech. If you bear with us very briefly.
Hello, everyone.
Ivana's saying hello. See, Ivana's here. It's just that it always goes... wait a minute. I'm going to do just that, actually. If you bear with us just for another 2 minutes, everyone. So sorry for the delay. It might be if we're not running in a minute and a half, then we'll do it and we'll make it work. Once you've got YouTube running, Ivana, let me know and we'll do it that way. Just have to deal with the 30-second delay.
Yeah, YouTube's running on my end.
Excellent, right? Which means you can probably see the title card, right, Ivana?
I can.
Excellent. Which means, okay, we're gonna do this thing. We're flying blind a little bit, but it's gonna be okay because it's gonna be a bit more like. Here we go. It's fine. We're running basically smoothly. Oh, anyway, right. I'm gonna get rid of that, and what we're gonna do is we're going to start, first of all, so Ivana's here. We can all see Ivana. Hello, I'm waving. Ivana's sort of sat on the other side, so it's a little bit sort of stunted. I'm so sorry, Ivana. I'll work out what the problem is. But it'll be fine because we're talking about a subject which is very close to my heart, which is slab track, which we've been waiting for the slab track episode for a very long time. People are very excited about the slab track episode because lots of people don't really know what it is. So without further ado, we didn't. Also, with our distractions, we didn't run through the slides to let you see what's happening. But first of all, we're going to do the news, which is become somewhat of a tradition on Rail Natters. So sit tight for a moment while I make sure I'm showing the right thing here. Yes, I'm going to whiz back to this button and press this button. Right, the first news item is that Crossrail has moved a train. They're putting out in the news. They're talking about the fact that they've been running a train through into the tunnel section. There is people can currently see a train whizzing through the tunnel, going past various stations and looking very exciting. It's currently on some slab track, which is nice. Although a mixture of different designs. I'm not sure if PORR have actually put any slab track in Crossrail. Do you know if you have any Crossrail slab track? I think a lot of it's they've used slightly different designs. I think it's
not on Crossrail, but we do have our slab track installed on a few projects in the UK.
You definitely do.
But not on that particular project.
So I'm going to pop up one of the. So in a minute, I'm going to pop up a picture of one of the sites that you've got some PORR installed at, which is the first one that it was one of the earlier installations that I knew of with PORR. Anyway, we'll get to that. The next news item, there's not really much to say about that. The next news item is that Anger has worked again because Perry Bar Station has been changed a little bit after the visualization that was put out by the council wasn't found to be very, let's say, popular. Everyone remembers the shoebox from a previous Rail Natter episode. Well, they've updated it, and it's now, they've changed the colour so that it's rust coloured. But it's still the urban realm around it is not particularly good, so that's not great. We're going to move swiftly on. The Williams review, another news item. The Williams Rail review is apparently less than 6 weeks away. I'm doing rabbit ears because it's been less than 6 weeks away for about 3 years now. So yeah, the thing that's holding the whole rail industry up and stopping us being able to do anything because we don't really know what's next is continuing. Oh golly, yeah. So that's 6 weeks away. We'll see. That's January. So we'll see if we've got the Williams review before January. Yeah, I don't think so. Next, this graph, fantastic graph that was put out by Carbon Brief, actually, is a summary of the outcomes of the Climate Change Commission, the UK Climate Change Commission, talking about what the UK needs to do to continue to match its kind of carbon budgets we've got for the next, for the period until 2050. We need to be at net zero by 2050, And in order to achieve this, current projections of policy show that we're basically levelling off what we can do. The hard stuff, i.e. housing and transport, is all that's left. We're decarbonising energy generation at a pretty high speed. So we're stuck with the tricky stuff now. And government, if they continue to implement the policy they've got now, won't be doing enough. So pretty radical things need to happen. So here we go. So you can see I've shown this graph before, this graphic, which is showing that 60% reduction in energy, 50 in industry, 40 in business, kind of 16% for residential, and transport is basically 3%. That's the reduction in CO2 emissions from 1990. So the hard stuff is what's left to fix now, residential and transport emissions. And the time for action was really about 20 years ago, never mind. And if you want a summary of that new report, the CCC report, the UK needing to cut emissions by 78% by 2035, there's an excellent summary in Carbon Brief, on the Carbon Brief kind of news website. I'd recommend going there and having a look. What's next on the news? Oh, yes. The Royal Borough of Kensington and Chelsea have replaced their cycle lane with a parking spot for 3 parked cars. Hooray! So that's very good, obviously, for no one. A lot of controversy that's happened around this cycle lane. Anyway, there we are. I'll let you all chase up on that, but just thought I'd point it out. Right, we're now talking about slab track again. We're on to the interesting stuff. So, before we do the intro credits, I've got a picture on screen right now, Ivana, actually it's 2 pictures. One picture is just of some ballast. There, it's just some ballast. And the next picture is a picture from Winchborough Tunnel up in Scotland, on the approach to Winchborough Tunnel, which uses, and I really hope it is PORR, not one of your competitors, but I think it is PORR. It's got the nice square.
That is our slab track.
That's it. It's got the nice square shear keys. You can see a load of people all scrabbling around it. It's got some nice Vossloh clips and the kind of the nice angular shoulders that I'm familiar with. And why I like this picture, Ivana, I'm going to audio describe it, not just for your benefit, but also because we have people who listen to this in podcast-only format, which is a bit strange, but they seem to like it. This picture is great because on one side, it's got on the right-hand side, it's got the PORR. The precast slab units have been placed and kind of being aligned, and on the other side is the old ballasted track. So there's a nice comparison of the way the two different types of track system look. So on the left hand side you've got ballasted track, and on the right hand side you've got so it's slab track, but actually the general catch-all term for the two different types of track form that I as an engineer use, one of them is ballasted track and the other is fixed track form, of which slab track is one. And tonight Ivana's going to tell us all about slab track. That's the plan. Slightly we've for some reason, because of my lack of professionalism, I've tied both of your hands behind your back to do this by the fact that you can't see what's actually on screen. I'm so sorry, Ivana, but I think we're going to manage. It's going to be okay. So, without further ado, it only really remains for me to introduce tonight's Rail Natter. Welcome to the show, everyone.
Thank you.
This is exciting. This is the bit where there's nice Ivor the Engine music playing, and everyone can hear us chatting too, but the music's nice too. There we are. What is slab track and why is it good? And we're about to find out. We're about to find out in moments. You can't hear this is the other frustrating thing, is you can't hear the audio coming through as well from the nice things we are. But while that fades away, the lovely Intercity 225 fades away, we have our first picture of very nice canted slab track, PORR slab track, with you see those square shapes, they're filled in, nice shear keys. And Ivana, so first of all, before we talk about slab track, tell us about PORR and tell us about what you do within PORR.
So PORR is one of the biggest Austrian construction companies, and we're a general contractor, and we build buildings and highways and roads and railway, ballasted track, as well as slab track, stations, bridges, tunnels. So we really are a general contractor, and PORR is one of the oldest construction companies in Austria. We actually celebrated 150 years of existence last year.
Yeah.
Which means that we currently have a history of 151 years. And our name comes from one of our founders, which was Arthur PORR. and he was an innovator in the area of concrete technology in his time. One of the things that PORR has developed. Sorry?
Yeah, no, I can still hear you.
Yeah,
Sorry, that's
okay.
fine. Keep going.
Yeah. One of the things that PORR has developed over the years is this specialty in slab track. So not only did we install a lot of slab track, but we have developed our own slab track system, and we did that together with our client, Austrian Federal Railways. Our slab track has been in track now for over 30 years, since 1989 in the current form. And I have to say it's been maintenance free since then.
Really, it's still maintenance free. So this, which like really touches upon, and I'm sure we're going to talk more about this. It really touches upon one of the main reasons why slab track is very good, particularly for intensive railways. And it's that, I mean, I was going to say it's almost maintenance free. Well, you're saying that it's been entirely maintenance free in the installation and.
This depends a little bit on the slab track system that you use. So not every system it really depends on the system. But with our slab track system, I mean, during the development, this is something that the developers were thinking about. How do we develop a system that is going to be something that has longevity, that is easy to install? You know, they also considered the noise and vibration aspects and what solutions they can put into the system so that, you know, it can have very favorable properties and can be adjusted to the project requirements. And you know, another thing is, once it's in track, you know, how do you make sure that it does not develop issues, that it can actually have a very good track record for the entire life cycle? So, you know, sometimes people say, well, what do you mean it's maintenance free? You know, it's like you can't have something that's maintenance free with trains running on it, you know, at sometimes very high speeds and, you know, many trains per day. But this is the track record that we have since 1989. And of course, you know, depending on the radius and the alignment of the track, you may have tighter curves. So you may have to grind rails at some point. But that's something that you would have to do on ballasted track or slab track. You know, you have to do inspections and those things. But the concrete part of our slab track has been maintenance free.
Yeah, in terms of the sort of equivalent maintenance, you'd be expecting to go through with, well, the frequency of tamping. So for people who are listening to this or watching this who don't know what tamping is where you essentially have a machine that has a load of tines that dip into the ballasted track. You essentially lift the track to its design position and consolidate the ballast to go underneath the sleepers to hold the track in its design position. For very intensively used railways, you have to do that multiple times a year. So for a high-speed railway, for example, like, I don't know, high-speed 2, having ballasted track would have resulted in an enormous requirement for on-track machines, for sidings to put those machines, obviously the carbon costs of fueling and maintaining those machines, as well as getting them to site, huge amounts of stuff that ballasted track essentially just avoids all that. Anyway, we'll get to all that good stuff.
You mean ballastless track?
Ballastless track. Thank you for setting me right, Ivana. I'm gonna. Yeah. That's not the first time I'm gonna have done this tonight. I'm just getting ready for everyone. Ignore whether I'm saying ballasted or ballastless. I'm going to get it wrong lots because it's confusing to say them repeatedly. But use your imagination as to which one I mean. And Ivana will keep me right anyway because I only loosely know what I'm talking about. Right. So I have interrupted you there, Ivana. So you work for PORR and you work in the slab track division of PORR, PORR AG.
Yes. So I basically do marketing and product management for our slab track system, which means when there's a project somewhere in the world, small, large project where slab track is being considered, if there are any questions that the client may have, you know, I'll try to answer those questions and, you know, like share information on our experience, or, you know, sometimes it's like, well, how do you install it? Sometimes it's, you know, like, what are the characteristics? it's not always, my work is not always just with the client. Sometimes it's also with other companies, which could be partner companies, whether, we provide the system and they install it, whether we have some type of a joint venture or consortium and we're working together. So, like whether it's a licensing agreement. So depending on the part of the world, we have various approaches for what might be the best scenario for that project.
Yeah,
so
definitely.
This is the part that I do. So I'll work with the clients, with other companies, in the railway construction industry.
And so we met at the Permanent Way Institution conference. Was it last year? Time has warped. It was
Yes.
last year, wasn't it?
Yes.
Crikey, 2020 has been a strange year. And
Yes.
very very rapidly it occurred to me that you have an incredible. I mean, you've been working with this stuff for years, presumably, because you have an incredibly good knowledge of the system and how it fits into the wider infrastructure, kind of the wider railway infrastructure as well. So, which is why you're the perfect person to tell us about SlabTrack tonight. You're holding your own against lots of grey beardy men at the Permanent Way Institution conference. No, I'm being mean. It's not everyone in the Permanent Way is old and grey and beardy. It's fine. I shave my beard, so I can make that comment now with impunity, which you can't see. Although maybe you can see it on YouTube on your second screen if that's working. Is that working? Is there a bit of a delay? Can you sort of vaguely see what's going on?
There is a bit of a delay, but it's working.
It's working. Okay, that's good. So roughly you can sort of see what we're up to. Right, so we're going to go back to that picture. So there we are, up in the top corner, which is good. So this picture, this is one, it's a picture of an approach to a viaduct. We've got a nice, what appears to be a tar-macadam subgrade with the PORR slab sat on top, with some different coloured clips as well, which I presume is to do with longitudinal restraint on the bridge, but maybe that's another discussion. In any case, it's a very fetching picture. We've already had people in the comments going, "Oh, that looks nice." But SlabTrack's not just about looking nice. Tell me about this picture. What does this picture tell us about?
I think this is an interesting picture because you see that you're approaching from an open section, you're going onto a bridge and then into a tunnel. So you've basically covered the three typical scenarios where you can have open section, bridge, and tunnel, and you would have SlabTrack. There are different things that need to be taken into account, of course, when installing SlabTrack on these three different structures. And there's different reasoning why the railway infrastructure owner decide to use SlabTrack. So, for example, in Austria, the Austrian Federal Railways have decided that if there's railway track in a tunnel, that it should be SlabTrack. This is partly because access to a tunnel is a little bit more restricted than to an open section. So even if the speed is not very high, if it's not demanding, as far as the performance, if the track is in a tunnel, for the purpose of increasing, I guess, like safety and reducing the need for the amount of maintenance in a confined space, like the decision is to build SlabTrack in case it's a tunnel. Austria and some other countries also have SlabTrack also in open sections and on bridges. This is also the case in Germany, and it will be on high speed too, where SlabTrack has been chosen for the entire length of the line, at least for the first.
For the first phase up to, and the likelihood is it'll be because of the length of open track between Crewe and Manchester. The chances are it'll be SlabTrack all the way into Manchester, probably. Which is good for you guys because you've got a shoe in. But we'll get to the high speed 2 is it's a good example of where it's going to be used, where SlabTrack's going to be used kind of at scale, really, isn't it? But as you say, we've seen SlabTrack. I mean, SlabTrack's been used in the UK for a very long time actually, but PORR has been used. So it was used on Edinburgh Glasgow electrification. It's used through the tunnels, as you say, to get extra clearance for electrification and also for maintenance. And it was also used. It's also been used on Gospel Oak to Barking, I think, as well. Is that right? Yeah.
That is correct. It's been used on Gospel Oak. It is being currently installed in Gasworks Tunnel.
Of course, yeah.
This is King's Cross, and you mentioned, Edinburgh Glasgow Improvement Project. So there were two tunnels. One was in Glasgow, which is Queen Street Tunnel, and the other one is in Edinburgh, which is Windborough Tunnel, where PORR slab track has been installed. And as you properly said, there was slab track in the UK even before. In fact, our slab track system replaced the existing slab track system, which just, it had to be replaced because of some issues where, operations had to be slowed down because of deterioration in quality.
It was the old British Rail sort of poured slab track, and I'll be honest to say it was installed in, shall we say, interesting conditions with a lot of water, and it turned into sort of crumbly cheese, which is why it was ready to be broken out and replaced with PORR. What was quite interesting on that job, we've gone off on a segue already. What was interesting on that project is actually that PORR provided some test sections to trial run what the demolition of what the construction process would be within Queen Street Tunnel, or maybe they reused some of your sections. But it was quite interesting seeing that collaboration to kind of make sure that when they got into the tunnel for real, everything went smoothly. It was quite cool.
There was a test track that was installed before any of these. This was in Asperby, but on Queen Street and on Windborough Tunnel, you mentioned clearance. Obviously, these are very old tunnels, and UK being one of the pioneers as far as railway is concerned, which was developed more than 100 years ago. The tunnels that were built back then, did not require that much clearance. But, here we are in the modern era, and a lot of the network, should be electrified. And how do you actually fit electrification in this old tunnel that does not have the clearance? So one of the things that we were able to do, or that, people working on the project were able to do, was actually to lower the track because PORR slab track system has narrow construction width and height.
Yep.
So this was not, it was also an example, slab's
advantages for getting
this construction height, on some of the projects in Austria as well, where, it was installed in these old tunnels. Yeah. So when you talk about why is slab track good? So, this would be one reason, in an old tunnel with at least our slab track system, it is possible to lower the track level and fit electrification.
That's definitely one of many positives about slab track. So yeah, this picture is good from a track engineer perspective. One of the things that causes me headaches, particularly in a scene like this, is the differential kind of the different structural properties of the support structure underneath the track. So you've got the embankment running onto a viaduct, then running into a tunnel, and all of these have different, for want of a better word, bounciness underneath the track. And slab track is quite a good way of managing those transitions between different stiffnesses. So it's another benefit of slab track, whereas ballasted track isn't quite as, the ballasted track gives you an immediate response. So if you've got something stiff underneath the ballast compared to something very soft under the ballast, there's almost no transition. You have to build something special underneath the track, essentially, to manage that different. So slab track's very good for that as well. And I'm sure we're going to continue saying good things about slab track through this piece. But the next picture, unless there's anything else you want to say about that nice curvy picture. Oh, yeah, go on.
I would like to say something. So, obviously, the fact that you have different stiffness, in an open section on bridge, depending on the stiffness of the bridge, and then in a tunnel, you also have to consider transition of that stiffness, in slab track. So this is something that has to be investigated. The best thing to do is to consider when you're designing the bridge, to actually consider, the slab track is going to be on top of it, and to integrate the design so that it fits together. And because how projects are tendered, this does not always happen. Sometimes the bridge is tendered and designed, and finished, and the track comes afterwards. So when that happens, then you have to consider, okay, so the bridge track interaction, is it favorable, or do we have to have special measures that we have to engineer in this case? So, for anyone doing these types of projects, the earlier you engage the slab track specialist, the better that track bridge interaction is going to be, and the longevity and the success the longevity of the track and the success of your project.
Absolutely, and certainly, it's always something that has to be considered, no matter what the type of track form is. But it's generally it's easier. Yeah, it should be, given, as you say, given the ideal situation where you're designing the structure and the track together from the very start. My experience has been that slab track is easier to coordinate that sort of a transition than is the case for ballast. So the next picture is of. I'm going to now describe it, which is, this is nice because it's showing some vertical geometry. So the previous one showed some really nice horizontal geometry with a nice sort of banking curve. This one shows, it's appearing to show a vertical curve to a rising grade. Again, you've got this, it's very clean, tidy track form. It's great. So yeah, this is a really nice picture of some track disappearing off into the distance. Tell us about this picture. Which is, yeah.
So the picture that you showed earlier and this is actually from a high-speed line in Germany. It's called VDE 8. And, it's in German, it means German Reunification Project. It's on the line that connects Berlin with Munich. It's not the entire length because some of that section was with ballasted track, but there was quite a bit of new high-speed railway built in slab track, and PORR has installed over 300 kilometers of our system on that line. So both of these pictures are from that project. You can see here that there is a, like you said, there is a vertical slope. This goes through a region that is very mountainous. So there were quite a few bridges and tunnels. And because of, this mountainous region, you would, there are also sections where, there is a significant change in vertical slope.
Yeah. So we've had an interesting question, which I think maybe we can tackle now, which is, David Shepard is asking, if slab track is so good, why isn't it everywhere? Does it cost more? Well, I mean, firstly, we've had slab track for a long time, but the idea of having, and I'm sure you'll talk about this in a bit more detail momentarily, the idea of having nice precast sections of slab track and making that work is maybe a bit newer as an idea, although 1989, that's not that new. But the other thing is the challenge is that certainly, and I'll speak for the UK government here, we have a government that's very fixated on the upfront costs and doesn't think so much about the overall long-term. So they think about the capex, the capital expenditure, and they don't necessarily think about the total expenditure. So there's a bit of a challenge in that if you're thinking about the total expenditure, slab track for intensively used railways can actually be cheaper overall. Indeed, for HS2, it certainly is. There are other, as we're going to say, there are other benefits to it. But if you're just looking at the upfront costs, certainly historically, slab track is more expensive. Like, it is more expensive than ballasted track. So that's kind of the challenge and the reason why we don't see more slab track, certainly in the UK. Ivana, I don't know if does that just about summarize it, do you think?
Well, as you pointed out, I mean, there is a little bit more upfront cost on slab track, but over time, if you think about the life cycle and, you won't have to do maintenance, especially the very expensive maintenance, it is a cheaper system. Now, when you think about that, it's a little bit, to be fair to, the governments, not just the UK government, any government, if you already have an operating line, it's like, well, you're not going to dig it out and, just install something new. And also, even when we're, making our own decisions in our own life, it's like if you want to buy a car because you need to move from A to B, it's like, what type of a car are you going to buy and at which cost? It could be that, it's better to buy a little bit more expensive car, but you only have so much in budget. This is, just to be fair. Now, of course, like it makes sense to consider slab track at least. And this is something that the Austrian Federal Railways will also tell you. Slab track is outstanding, it's great, but even they, when they're making their decisions, they take a look at the use case. So sometimes it makes sense to use ballasted track. You know, it's like if it's not a line that's used a lot, if the speeds are kind of not that high, you know, it's like it makes it, you know, ballasted track would win the case. In situations, especially, you know, modern mobility, you know, we need lots of, well, hopefully, we want to travel by train and we want to get from point A to point B in a fast way. And we want, you know, that track to be quality for, we want high comfort of our ride. So, you know, in modern days, you know, there is more and more need for high speed railway. So this is where, you know, slab track tends to win the case, especially if you consider the fact that, you know, if that railway line actually has many trains running on it, you know, per hour, you will have a difficult time finding opportunities to maintain the track.
Absolutely, yep.
And also, you know, like if you think about the total cost, it ends up being cheaper. But it really has to be, you know, like a decision based on a use case to decide, you know, which makes sense.
Yeah.
And also, you know, budgets decide everything. If there's money in the budget, then maybe you can go with the more expensive initial upfront cost.
Which is why it's so important to kind of educate policymakers and decision makers so that they look at the whole life cost and not just the initial upfront costs. Which hopefully this video is part of doing. So that's a tremendous picture. You know, we've been doing this for 31 minutes, Ivana. I told you time flies. And we're only on slide. We're now on slide image 3, which is it's a terrific image showing PORR, the PORR sort of precast slabs being laid out in what looks like quite a straightforward manner. Actually, you've got a train on one. Or is it a train? Actually, you've got what looks like it will be a train sat on one side with a wagon with a load of precast units, and then just a fairly straightforward looking kind of front loader lifting them off and putting them into place. Tell us about this image, and I suppose this is about how this particular design, how the PORR system works, how you install it.
So when we talk about slab track, you know, for people who are not very familiar with that, there's basically 2 ways to do slab track. One is to have like basically, you know, like blocks or sleepers, and then use a lot of in situ concrete on site, fresh concrete to, you know, that you pour on site. And the other one is to use these precast slabs. And I mentioned that the decision making at the time of development was to, you know, let's consider what we can do to make installation easier and to make sure that we have very high quality. So the decision was made to go in the direction of precast slab, which you can see here. These slabs, the standard slab is 5.2 meters long. They could be shorter, you know, if you're approaching a bridge joint, if there's like a reason why, you know, like you need to end someplace, or if there's any type of, you know, like reason why, you know, it would have to stop at a certain section. But when these slabs are produced, you know, like they're produced under controlled conditions in a factory. So only the slabs that actually meet the highest criteria, they leave the factory. So when they are brought on site, the adjustment, it does not require too much work. So because the geometry is already in the slab, and then, you know, the amount of concrete that is necessary is also much smaller if you have a precast slab, because if you think about it, you know, most of the concrete is already there. So the combination of all of these things, you know, the high quality of the precast slab that leaves the factory, less concrete that you have to have on the site, you know, it just ensures that you have higher track quality when installed. It also helps as far as, you know, the number of people you need on site for adjustment, because if you had these blocks and fresh concrete, just adjusting that track is much more time intensive. It requires more people. This, of course, then affects also the safety situation. You know, it's like if
Yep,
you need
yep.
fewer people, then, you know, like you have already improved the safety situation on site.
Yeah, and it's so as you say, for people who people often have, or certainly I've seen in the past lectures about slab track that have all these pictures of slip form machines where they're kind of going along and slip forming, and it's kind of like that's sort of what slab track looked like maybe 30 years ago, 40 years ago. But you know, modern slab track, PORR as the kind of, for me, the kind of the pinnacle of this type of track system. It's essentially a precision engineered product, isn't it? It's not. We're not talking about something that's sort of lumped in, poured, sort of wooden form work. These are very, very precision molded. Every single fitting is laser accurate to the track alignment of that given unit. The concrete accuracy of the form is incredibly good. Like, these are precision engineered bits of kit.
I'll say two things about that. You are very correct that, you know, it's extremely precise. So the critical key points on the slab have the precision, which is within plus or minus 0.3 millimeters. So it's not even a millimeter, it's 0.3 millimeters tolerance. So it's very precise. But on the slip form, if you're building in an open section, you can't lay slab track just, you know, like on, you know, just like in an open area. You do have to prepare a layer. So you may actually, you know, like I would say, regardless of what type of system, if you're in a tunnel, you have the tunnel invert, you know, which is kind of fixed low subsidence surface. But in an open section, you would still use slip form because you have a layer underneath slab track, because you have to have certain amount of stiffness of the area that you lay slab track on top of.
Yep.
This is what makes it possible to have maintenance free, you know, for the throughout the life cycle. Because if this was, you know, if this was a soft surface, you could not ensure that those slabs will remain in the position without any type of settlements, or, you know, especially problematic is differential settlement.
Yeah, absolutely. Yeah, it's so for example, the old British Rail, what was called packed, was essentially it was two tips. You had mass concrete underneath, and then with the reinforced concrete, slip form reinforced concrete on the top, which would then have the fastening sort of nestled into it. Essentially, it was a top-down form of construction where you had the rails and everything else sat underneath, and then you'd slip form the concrete. And it was certainly less precise than modern methods of slab track construction. So yeah, things have moved on a little bit since then. Even there are other types of slab track system. You know, as you say, sort of booted twin box sleepers is a common the Sonneville LVT system, where you have got these sort of booted sort of twin block sleepers. Those sit in and then you pour concrete around them. It's another way to do slab track. So that, yeah, you have this. There's kind of a variety of different systems, but it's much more precision engineered than it certainly used to be with the old BR system. So what else is going on in this picture then? Because there's so yeah, it's a fantastic picture, really. This one, I love it.
I see somebody has asked the question: is there a hinge effect between adjacent precast panels? So if I understand this correctly, the question is really, you know, what type of connection is there between panels? And I will say this again depends on the slab track system. Our slab track system actually has a joint between the two adjacent panels. It's minimum 4 centimeters. It could be longer. It could be a little bit bigger than 4 centimeters. And this is actually by design, because the idea is to, you know, if there's any type of stresses in the track, you know, it allows the track to breathe. And you can also run, our system is not post-tension system, which some systems are. Some systems just have, like, you know, concrete throughout for the whole length. And, you know, if you know a little bit about concrete, you know that cracks in concrete can be problematic, especially when you have, you know, a train moving at a high speed and all these dynamic loads on the track, you know, like, you know, cracking of concrete can be problematic. So one of the ways that we design, that we deal with preventing these cracks is also to allow this joint in our system. So the two panels in our case are not connected, and the stresses are not then, pushed into the next panel and into the next panel in the same way they would be if the whole thing was connected.
It's a continuous, yeah. And if you do a continuous PORR, you need to install expansion joints in a continuous type. Anyway, generally you'd have some form of it, or you can have forms of expansion. So yeah, it's in a way, I suppose they're acting like very long. They're almost like very, very long sleepers in that sense. They're kind of discontinuous single pieces. Yeah, good question. Thanks, Owen O'Neill. There was another question. Where did I spot it, which is quite a good one? Matt Reed is asking, and I think I can answer this one based on HS2's work. I'm hoping that they're going to publish their paper on this, which is, does the cost difference in installation of slab track and normal track outweigh the maintenance costs? How long does it take for the cost difference to have an effect on one's budget? Well, that depends on every project, of course. Sometimes you might find that it doesn't. If you've got a lightly used railway line, then you might find that it'll never, the balance doesn't work, and you have to look at it on a project by project basis. But for intensively used railway lines, which are which is a lot of them nowadays, frankly, yes, the slab track will be cheaper if you look at its total, even if you look at like a 40-year period, not even the 120-year design life of the project, but even if you're looking just at a 40-year period, which is about the renewal cycle for a track kind of regular track system. And there's a paper that HS2 have done that describes this, and it describes a methodology to follow for projects. And I don't think they've published it yet. I'm kind of bouncing up and down in my chair, waiting for them to publish that methodology, because people being able to follow that methodology would be very useful. Yeah, lots of work that was done by Niall Fagan and his colleagues at HS2 when he was in charge of track. Some really good work there. I suppose that I don't. Does that match what you think, Ivana?
You are very correct to say that it really depends on the project. So, we have a study for one project in Austria where it showed that the break-even point is before it even reaches 20 years.
Oh, wow.
On a different project, it could be earlier or later. It really depends. But this is a decision that is made. You have to think about what factors go into calculating this. And some of these factors will be really the use case of the line. Does it require a lot of maintenance or not so much? And it also depends, when you say, okay, so like how much more expensive the question was also in terms of cost, the initial upfront cost. And your response was that this depends on the project, and I will completely agree on that. And I'll just give an example from real life, because, when people ask, well, how much does it cost? It's similar to saying, well, I'd like you to build me a house. How much does it cost?
Yeah.
So you have to ask, well, what type of house do you want? Where is this house? How much does labor cost in this area? What is the house supposed to have? So, you can have a general orientation on how much something costs, but it might be different depending on the specific case, which country, on the specific project. Like what will be how will this track be used?
Yeah, I mean, we're getting you've spurred in. We've got a million questions coming through now, but I'm going to pause those, conscious that we're already 42 minutes in, and go to the next picture. Unless there's anything else you want to say while this picture is up.
No, I think we can move
cool.
on.
Let's go to the next picture, which is also, by the way, Ivana, we're getting loads of comments. In fact, you'll be seeing them of people just loving these photos. So thanks to PORR. These are all PORR's photos, or your photos, actually, aren't they? They're all like straight out of the presentation, I think, that you gave at the PWI. So there's a lot of love for these pictures. There's some very satisfying railway pictures here. So all the nerds in the chat, yeah, you're welcome. This picture is of it's a viaduct, but there's no track on it yet. It just looks like the structure's been built, and they've built the earthwork approaching it, but there's no track on it. But what I can see in the bottom left-hand corner are a few PORR units piled up. So tell us about this picture. What's going on here?
So you mentioned that this was taken out of the presentation, and in that presentation, one of the points I was addressing was the importance of the logistics, and how, especially on large-scale projects, it's like you have to. One of the most important things to consider when building railway, which is a long line construction site, so it keeps moving. It doesn't matter if it's ballasted track or slab track; it just keeps moving. So you have to consider the logistics for that, and it becomes especially important in the case of slab track. and in case where you have different civil works contractors building different civil works as part of different construction lots, and they may have different timelines on when they should be finished. So the reason why we used this picture was also to say that, if you have ballasted track, usually the progression of construction site is very linear. You start from one end and you keep going forward. So in case you come upon a bridge that is still not completed because, it's due to be completed in 6 months, or there's some type of delay, like in tunneling, it could be no fault of anyone that there's a delay. It could be just geological things, especially when you have like a condensed timeline of completing a project, slab track does allow you flexibility because you are not bound by the very expensive, cost-intense machinery that builds ballasted track. With slab track, you can have actually parallel work fronts in different sections. And the machinery that is required is a little bit system dependent because we said there are various slab track systems, but usually it's not that cost intensive like it would be for ballasted track. So I think, the discussion in that case was the logistics, and when you have situations where the civil works are not completed at the same time, but you would like to have progress in construction of track that comes on top of that.
And it comes to things, logistics are hugely important for things like, like if that bridge wasn't there, how do you get the stuff from one side of the valley to the other? For example, how do you get, if you've got the depot where all of the PORR units are being transported to, is there, and there's a valley in the way without a bridge, that's a bit of a problem from a logistics perspective. So it's important that, so in that case, it'd be quite hard to lay the track on one side and lay it on the other, waiting for the bridge to get built. Ideally, the structure's done, and then you can just and then that way you can essentially use the structure as a whole road. This is actually a problem in a few different sites on HS2, is getting the construction staging right, that they can use these structures as the whole road to actually get the materials from one end of the construction site to the other. There's an interesting question. Oh, go on. Yeah, sorry.
In this case, I mean, we can deliver our panels by rail or, use it by road. So you could, just use regular road and deliver the panels, but you could not have construction progress. Maybe in this case, if it's slab track with our panels, you skip that bridge and you come back to it later, but you have continued progress in other sections. So bringing the panels is less of a problem than if you have to, build with ballast, and that machine cannot move across the bridge before it's finished, and you cannot continue building the track beyond.
Yeah, so actually slab track is affording you maybe a little bit more flexibility in terms of program than perhaps you have with ballasted track with the automatic track laying machine. Yeah, that's very interesting. And we've had a question about what goes underneath the slabs, and I think we'll save that for maybe a couple of slides, because we've got a kind of an installation picture, I think, in maybe two slides away. So we'll flick on to the next picture, which is of it's another stunner, actually. I've twisted it around a bit, actually, so you can see this is, again, you've got high-speed lines in mainland Europe are just so pretty to look at. You've got a tunnel portal, which has got some nice slats in it to dissipate aerodynamic forces. You've got a viaduct over a steep valley. Then you've got a short but quite deep cutting, followed by another tunnel. So it's all happening here. It's a fantastic picture. Tell us about this one. What's going on? And in fact, there's even some switches and crossings. There's a giant crossover between the two tracks in the middle of it as well. So there's a lot going on here.
That is an interesting image that kind of shows, all of it, you mentioned. This was on that high-speed line VD8 in Germany. And I mentioned earlier that it's a very mountainous region, so there were sections where you had similar situations, but most of the time, the sections where you have, where you go from one tunnel onto a bridge, a little bit of open section, and then into the next tunnel, usually they were a little bit longer. Here you have a very condensed version of all of that. And sometimes, the topography just forces you to have this type of scenario.
Yeah, it really is quite impressive. I mean, that's why I get upset when we're burying high speed 2 underneath tunnels for a lot of its length, which is good in a few cases. It's fine. It's reducing some of the at ground level impacts, but we're missing out on the chance to create some absolutely stunning sort of sceneries for not only for the people in the trains, but actually I think it's quite a fetching bit of infrastructure for people to see next to the railway. Anyway, right? That's another subject. What we're going to do is.
But may I comment on that? So like what you mentioned was also a consideration for Deutsche Bahn when they were deciding their alignment, and they said they were interested in having the passengers on a train having this experience of seeing the nature, but due to topography they did end up with quite a few tunnels, and some of these tunnels are quite long. There was just no way to go around that, even though like they had that idea of enjoying the scenery very much in the forefront when designing, and they still allow this luxury of seeing the scenery to the passengers, but they just couldn't. The line does have many tunnels, and some of them quite long.
Yeah, it's this line. I've never actually ridden on this one. I did a trip. I did a trip in Germany before this line was. I think before this line was operating, or I skipped it because I'd probably chosen a cheaper ticket as well because I'm Scottish and I don't spend enough money. In any case, absolutely stunning. So we're talking about construction, and I think the next picture is of some people in a tunnel, installing, or rather maybe they're checking actually some post installation. PORR slab track. So tell us what's going on here, and then we'll maybe answer some of the questions about slab track that have come up. But tell us about this picture.
I'm just waiting for it to change on my screen.
They're inside the tunnel, and you're about 30 seconds behind. So they're currently rolling. Oh, yes. There we are. Go on, tell us about it.
So I mentioned that the philosophy with our slab track is to have this precast slab track. So in this case, they're actually doing the adjustment of the track. When the rail material is available, of course, like to reduce the number of steps, it's the rail is actually put on slab, and then it's measured from top of the rail. And in this case, you see in the middle of this image, you see the surveyor and you see a worker on the side. In each of the slabs, there is a spindle opening. What the worker is holding is a spindle, and these teams they work so well together that they know, depending on what is shown on the screen, that they maybe need half a turn, a quarter of a turn to achieve the very precise alignment. Now, this is possible partly because the slabs are put into location with already a precision of plus or minus half a centimeter. So it's already, like when it's put into location, it's already pretty precise. And then this is the final adjustment that takes place. And once the surveyor gives the green light, says, okay, we have achieved the precision. You see in the middle these square openings, they're tapered. This is where the concrete is poured. And then, of course, you have to have some type of formwork and shuttering put on track before that. But then concrete is poured, and that would be the last step of installation. If the railway material is not available, because, very often for these larger projects, the rail material is 120 meters long. So if there's a tunnel or a bridge that has not been completed yet, it is possible, because of the very high precision of the of these critical points on the slab, to measure from those points and install without the rail material, and then when when civil works are all finalized, to bring in the rail material.
Yeah, okay. So the little square opening there, those are called shear keys, right? Is that how you describe them, as shear keys?
They do have a function of a shear key, yes.
Yeah. Okay. So they function like a shear key. Okay, yeah. That's me just oversimplifying things. So while we've got this picture up, so there are a couple of different things. So the construction of take us in the layers of construction for PORR. Okay, it varies between projects, but a typical example from, say, you've got the subgrade, so you've got the earthwork built up, say the subgrade has been built up. Is it then a mass concrete pour and then the slab on top and then the shear key is added? Is that generally the layer of construction? So is that one example?
So if you're talking about an open section, so earthworks.
Yeah.
So, you would start with frost protection layer, which is system independent. You always have to have this frost protection layer. And this is something, that, like compactness of that and stiffness is prescribed, so this has to be of a certain level. And on top of that, for our system, you would have a concrete bearing layer. And then our panels come on top of the concrete bearing layer. And the concrete that is poured into these openings, that can be, minimum is 4 centimeters under the slab. It could be also a little bit higher depending on the section where it's installed and the requirements for that section. But if you're building, as in this case, in a tunnel, basically you have a tunnel invert. So you just have, like there is some type of fill material, some type of, concrete material for, to make the level of, which is system independent. And, in that case, our slabs would come on top of that, the layer of self-compacting concrete that is poured through the openings. It actually fills the space under the slab. So, that's the basic.
Yeah. Do you have so do you use tarmacadam as a sub layer as well instead of concrete? Is that one of the options that you have for open track?
This has been used on a couple projects. One of them was in the UK, one of them was also in Austria. So this is definitely a possibility. Again, it depends on the requirements of that railway line. And what the decisions are, but it has been used in the past. In this case, like in a tunnel, in this case, I'm referring to the image.
Yeah.
In a tunnel, usually it would be some type of concrete material. But I believe on Gospel Oak that it was tarmac.
Okay,
because that's an open section.
I believe that's the preference for HS2 as well, is that it'll be laid, there'll be a tarmac layer with the, I believe, but I might not be right on that. Certainly, when I've chatted
like from what I know, this will have a layer of a concrete base layer. But this is something that obviously once we get into designing those things,
the final design will determine it. Okay, yeah,
right.
And then obviously within tunnels, generally you'll have the this example. It's a bored tunnel with lots of nice concrete lining segments. Then there'll be the civil engineers will have put a layer of kind of shaped concrete that'll be underneath. That's almost like a bit of a road. And then the permanent way, the track people will come in, put their special concrete layer down, and then the slab will go on top of that, depending on sort of the construction process. In Crossrail, certainly when I walked through one of the Crossrail tunnels, you have the concrete lining, and then there's sort of almost a roadway that's banked depending on what the curvature is, that's banked, and then a little bit of layer of mass concrete would go in before the slab would go on top of that. So quite a variety for the people who love concrete out there. Plenty for the concrete engineers to do. All manner of different exciting concrete mixes to come up with. So this I think one of the things this picture is that precision that you've talked about, because high speed track or indeed highly intensively used track, doesn't have to be high speed, requires very, very tight tolerances. The tolerances of on the Gotthard base tunnel, I think is the most crazy tolerances I've heard. They had tolerances of like 0.1 millimeters every 10 meters, plus or minus. So this tiny little box of space that the rails had to fit in. But for high speed lines, generally that tolerance is about 0.5 millimeter either way. And you also need to be able to therefore adjust the rails very carefully when they've gone onto this slab track. And so that's the ability to just finely tune is something that these slabs are very good at, right? To make sure the rails are in the right place.
The point is obviously with slab track to achieve very high precision if you want to have something that is very low maintenance, because with very high precision of the track, and in fact, it has to be very fine precision of the rails, because that's where the train is running on. this affects the ride quality. This also affects, how much wear and tear there's going to be. So obviously, if you don't have very high precision, there's going to be more wear and tear, which is counterproductive. This is, you're installing slab track so that it could be with low maintenance, which is why precision has to be very high, as you mentioned. I just want to mention something because we mentioned high speed 2 and tunnels, just to make sure that that we're not confusing anyone. So POD has been selected to supply the slab track system for open section and on bridges, but tunnels will be decided as part of future procurement because multiple systems can compete there.
Yeah, I was going to say I figured that my understanding was that you had the open sections and the bridges rather than the tunnels, which are often tunnels. Yeah,
but
it's a slightly different world for the track within a tunnel is always slightly can be slightly different. PORR can do tunnels, but yeah.
Not only can it do, but we actually provide many benefits when installing in tunnels, and we're obviously interested in offering also for tunnels. But this is out in the future. Let's see.
Let's see what happens. Fingers crossed. Hey, there's no. I can be commercially biased. I don't care. There's no one shouting at me here. So it's not the BBC. I don't have to be like other slab track providers are available. I mean, they are. But anyway, PORR is.
But I think I should be fair.
Yeah, that's right. Well, you're the voice of reason on this podcast, I think. Actually, on that point. So as a track engineer, I always hope. My hope is always that the installation will put the rails precisely where my wonderful 3D rail strings are supposed to be. Because if they do that, the wheel set, the trains will run through beautifully smoothly. There'll never be any wear or damage, and it'll be marvellous. That's obviously never going to be, particularly for the existing railway infrastructure, for all sorts of reasons, that never really quite happens. Every time there's a diversion from the designed alignment, actually, basically, even with my alignment, every time you basically change the direction of the wheel set, you get energy dissipation. And that can be in noise or in heat dissipation into the rail and damaging the rail. It can form cracks, all sorts of things. So that's why, the closer you get to the perfect design alignment, the closer the rails are to that design alignment, the less of that energy dissipation happens. And that's why you get this long life of the asset, which is why slab track is so good. So what I've done there is basically heat-heated or mansplained exactly what Ivana just said, but with my track engineer hat on, so I can get away with it. It's okay. So it's about that. The closer you can get to the perfect designed alignment, the happier the track will be, and the less your train will make bouncing and bumping noises, which is good. Crikey, it's already... What time is it? We've already smashed the hour, crikey. This always happens. It's because it's a good topic that I'm finding interesting. If you're finding it... If Ivana, you can just give... If it's awful for you, you can just tell us and we'll leave you in peace and quiet. But everyone in the chat is loving it. There's loads of questions flying. I'm struggling to keep up with the questions. There are so many. People are fascinated.
May I make a little comment on ballast track and what you were saying about, the design? So, when you build ballasted track initially, you have high quality, but the nature of ballast is such that it actually provides some elasticity to the track. So every time that the train moves over track, the elasticity, like the ballast, is elastic, it moves a little. So many times with the train, with many times of the train running and the ballast moving a little bit, of course, that alignment deteriorates over time. And this is what slab track is supposed to help avoid, because it is fixed and, it does not, it's, the concrete parts are not supposed to move. The quality of track is supposed to be there for the life cycle.
Yeah. And it's part of the reason why you can enable better clearances. It's partly because the track form can be more rigid, but actually it's more about... So when I'm doing clearance assessment, for example, for electrification or just for enabling sort of larger trains, freight trains, the reason why slab track is good and it allows me to, I don't need as much space, isn't so much that the train, it's not about the track necessarily moving at that point. It's about the fact that between maintenance cycles, the track is going to move less. So even if the ballast and slab track, particularly with modern fixings on slab track, it can be as... it's not like a completely rock solid system. There's always a little bit of give in the elastic fastening systems on the slab track, just as there is with ballast. But the point is that between maintenance cycles, slab track will be exactly where it was when you installed it, in theory, whereas ballasted track is expected, as you say, it's that elastic property. It's expected to degrade a little bit, so we have to have wider tolerances for ballasted track to enable that movement. Talking of movement, this is another fantastic picture. Is that kink in the viaduct supposed to be there? That's in the distance. It's quite something. Is that just a natural design of the viaduct? Because can you see the wibble in the picture there, Ivana?
So
you're allowed to say pass. You're allowed to say pass. Yeah.
This is no. I mean, this is actually one of the images that that really illustrates the point of how important it is to have the track to have the bridge designer consider slab track that comes on top of it. Because you can see that, you know, like the bridge there also, you know, like in the bridge joints, you can see that the bridge supports are different, so the bridge moves differently, which does present some challenges for the slab track that comes on top of that. So, you know, this was the situation on this project, and this was actually the design of the bridge was awarded. It did get an architecture prize. But then when you put slab track on top of that, you have to have some type of mitigation measures to compensate for the movement in the bridge joints.
So this is longitudinal movement we're talking about now. We're talking about, so from one end of the bridge to the other, longitudinal along the bridge rather than sort of, I'm trying to work out how in 3D I can represent it. I can't. If you've got the bridge going like this, also, it's sort of this movement rather than, so it's longitudinal movement, right?
It's also vertical movement. If you think about, you know, it's like, especially in the bridge joints, you know, it's like if you have a soft bridge, so to say, you know, you would have more vertical movement. And of course, you know, if the train is running on top of that track, you know, at a very high speed, that rail has to be in a fixed position, you know, and there should not be like, you know, on the bridge joint, you know, you cannot have a situation where there's a big change in the vertical movement and a big jump. So this is where I say the track engineer, then the slab track engineer has to go and, you know, like engineer special solutions, you know, like to basically compensate for all that movement and still maintain, you know, like high precision of the track on top of it. And that image illustrates that especially when building slab track, it's something where, you know, track bridge interaction is very important, and the earlier that the slab track requirements are considered, you know, because in the end the train is going to travel on top of rails, so, you know, the precision of that rail is very important. The slab track supports the rail, you know, the bridge supports the slab track. So it's best when the design of this is approached from considering the entire system and each of the components and how they integrate with each other. Because you can build a bridge that is according to all the requirements and regulations, and yet you haven't considered what comes on top of that. So, you know, it just illustrates the point that the earlier you consider slab track, the better. Absolutely.
It's something that on every single project I work on, it's the projects that are successful are the ones that have proper design integration, proper early conversations between the different disciplines of civil engineers, track engineers, you know, the overhead line electrification engineers as well. All of these different systems need to be, you know, the earthworks engineers, of course, all of these different people need to be having those conversations early doors, because ultimately the train doesn't care what's underneath the rails. It just cares about the rails and the position of the rails. The train is not interested whether it's a bridge or an embankment or whatever it is. It just needs to have a good, clean running surface, a good, smooth, high-quality alignment. That's another fantastic picture. And again, you can see these are great construction pictures, because you can see there's this sort of staging of the works where you've got this track, this temporary way that's being, like, actually it won't be, it'll be the permanent track that's being put down and used for the train sort of running along on the top. This engineering train. It's brilliant. Love these pictures. They're great. There's also some really good questions. Sorry if I'm missing your questions. Do remind me. In fact, you know what? I'm going to ask the big question that I've been asked a lot now before I forget. So lots of people in the chat have been asking about noise. and the difference in noise levels between ballasted track and slab track. Ivana, what can you tell us about that?
This is very system dependent. So it depends on I mean, it depends in general, what area you're in is going to differ, like it's going to be noisier for both or less noisy depending on the area. But then between ballasted track and the different types of slab track, it's very different. So the tests that we have done show that actually our slab track system has properties which are more favorable than ballasted track, which sometimes is a little bit unexpected.
Yeah.
But when I mentioned, I don't think that this hour allows us time to go into all the details of the design.
Episode 150. We'll go into this. We'll get a paper on the two and we'll compare. Because honestly, that would be fascinating to look at the two. Because it's a question I get asked a lot about slab track noise. But that's interesting that those numbers have come up.
It doesn't mean that it's more favorable for slab track, period. It's just in the particular case of our slab track, because of how it's designed and these integrated properties of it. So if anyone's interested, after this, you can ask me a question.
Yeah, definitely. It's that's absolute. Oh, I'm intrigued now. It's the fiddly detail that rail natterers absolutely love. Obliteron, it's very kind of you to say. That you're enjoying these and learning so much from these natters. I do too. I absolutely love them. I've been looking forward to this one for a long time. Next picture. Oh, so this looks to be the same. It's another picture. Fantastic, lovely big picture, which no one can see because I've not pressed the button here, which I'm going to do now. There we are, everyone. We're back. Lovely big picture of the same viaduct, I think, but from the other side. So it's the other one was an aerial shot from the other direction. This one's from the kind of the other side where the tunnel portal is, and it does show there is quite a vertical dip in the bridge, but that's too perfect to not have been engineered that way. But it's quite interesting that they selected it. It's very elegant. It's quite nice. It's absolutely stunning. So what is this? Is this a similar picture saying the same thing, Ivana? What's this picture covering?
That is the same bridge. That is the same bridge, and it's a long bridge. I think it was a little bit over 2 kilometers long.
Oh wow, yeah.
And you can see, the earlier picture also showed the shadows, and especially different times of the day. Architecturally a very pretty bridge. They considered the environment and everything, but then when you build slab track, then you have to do a lot of testing. When you build a bridge, this is something that I don't know how many of the people in the audience have expertise in this or are aware of this, but anytime you build a bridge, there is going to be some type of settlement of that bridge for, the amount of settlement is the highest in the early days.
Yeah.
So, and, on this project, some of the bridges were built, not this particular one, but there were some other bridges that were built 10 years before slab track came on top.
Wow, 10 years.
Yeah.
Crikey.
Yeah.
So you're looking at
that was a little bit on the extreme end of it. Like I said, this particular bridge was not that was not the case, but that's just sometimes how construction projects go.
Yeah, I was going to say that's a long time, but yeah, I mean so a long bridge has all sorts. Yeah, it's basically another entire topic. Yeah, kind of track bridge interaction or track structure interaction is like a huge subject in and of itself. But it's the longer the structure, the more you have to think. The more challenging it is to engineer for that difference. What we're talking about for everyone in the chat is the difference in expansion. So one of the things, not all the things. Sorry, one theme of this is the difference in expansion lengthwise of say the rail expanding under heat or stress or cold, the bridge, the concrete of the bridge deck expanding at a different rate, the slab expanding at different rates, the concrete underneath the slab, all these things expand at kind of different rates, and the way that they interact is kind of key. But also vertically, as you were saying, the different rates of settlement between an earthwork, between different parts of the structure. So there'll be a different rate of settlement for those arches than there will be for the intermediate viaduct piers, I'd imagine. They'll do their best to engineer it out, and they'll also probably, for a bridge that's 2 kilometers long, there might be different geology under one end of the bridge to the other, and you might find that they've settled at slightly different rates. There's all sorts of things that you have to manage, and that's if you're coming in 10 years later, that's a bit of a challenge, right, for the slab track installer to make sure that they've got enough capability to accommodate the differences in levels compared to what the position the bridge should be in, right?
I guess, like the level itself, you could compensate for the level. It's like if you have to fill a little bit more material, of course, if there's enough support in the bridge or something like that. But the bigger issue is like the movement in the bridge joints. So it's something that, like that would be the sensitive point, especially for, rail. So like it would create a little bit of sensitivity.
Stress buildup, yeah.
Exactly. So, this is something that that is very important when building slab track to consider, like what is the maximum allowed movement in the bridge joint.
Yeah. And it's So
and the higher the speed, the more sensitive everything becomes.
Absolutely,
of course.
Yeah. Those tolerances just get tighter and tighter as the speeds increase. Yeah, and there's all sorts of different things the different disciplines can do. We can install ZLR clips, which are zero longitudinal resistance clips, so the rail can kind of move freely. There are all sorts of different options we can do. Anyway, as I say, that good grief, we could get lost. We've already talked for 10 minutes about it. It's a fascinating subject. It really is. But I fear we must press on. Actually, we should have talked about the construction of slab track for this picture. I made a mistake. This is a really good picture showing what the construction of slab track looks of the PORR type of slab track looks like in really great detail. So this is a picture of this is Germany again, I presume. This looks like a very Deutsche Bahn tunnel portal. In fact, I'm sure I used this portal as an example, a video from a train coming out of this portal as an example of sonic boom through tunnels. Anyway, and the picture shows what appears to be a tarmac Adam surface actually, with the concrete. With the kind of the layered and reinforced concrete, and then with the slab, with the precast slab unit, the PORR units placed on top. I'm audio describing for our podcast listeners. This is a brilliant picture. I absolutely love this picture. Absolutely perfect for showing the construction type. Ivana, tell us about this picture.
Okay, so I have to correct you on this one. This is actually in Austria.
Oh, dang, it is Austria. Oh, well, there we go.
Yes.
Fool me.
So in this case, like this is a bypass tunnel for freight trains. And the reason why there's tarmac there is, I don't remember the specific details, but it had to do with dewatering and, they were trying to actually optimize it somehow, and asphalt or tarmac allowed that. I mentioned before, the concrete base layer in an open section, which you can see here, but as you go into the tunnel, you don't have this, you just have the tunnel invert.
Yeah.
But this line is for freight trains.
Ah, okay, fascinating. So it just shows the variety of use cases. It's not all just about glossy high-speed lines. You've got Gospel Oak Barking, which is an urban, metro railway essentially. This is a freight line. So there are some people asking questions about the different use cases. For example, freight. This is a freight railway, so it shows that it's applicable in all sorts of different conditions.
Yes, and I mentioned in Austria, if there's a tunnel, the decision is to actually put slab track in because it's a sensitive area to go into, and do maintenance and repairs and things like that. Of course, inspections are done, but that does not, you can do that during night hours when there's no operations.
Yeah. Anyway, this is a brilliant picture. I absolutely love this. It's fantastic. Even if I don't know my geography very well, I stand to. Wait a minute. Let me wait until I get the next one wrong as well.
If I may just point out, like if you see this picture, it does not mean that that's the standard how it has to be. So obviously, it's always a consideration of on the project, and this was the first time that it was built this way in Austria. So the design of this with the tarmac underneath was like the first time it was implemented that way. Yeah, definitely worth highlighting. There are lots of different ways to use the PORR precast slab units. They sit on top of a variety, all manner of different types of overall track construction. So
Now I'm getting very happy now because this is a picture of it's not just any switch and crossing unit. This looks like a very high speed switch and crossing unit. I'd say, maybe not 90 miles an hour. Like maybe it's a 130 kilometer an hour sort of, maybe 140 kilometer an hour sort of turnout. I don't know.
This line was designed for 300 kilometers per hour. This is the same project in Germany.
But yeah, the turnout. But I suppose the turnout. Yeah.
Yeah, I don't know what the diverging speed is, but like the main line is supposed to be 300 kilometers per hour, and
So yeah, tell us about. So this one is. So this is a switch and crossing. So this is where it gets tricky, and this is one of the reasons why slab. It's another answer to why slab hasn't kicked off quite as much. Certainly in the UK, is the challenge of transitioning. If you've got lots of S&C, transitioning on and off slab track, if you haven't got a slab solution for the S&C, is more problematic. Which is why this picture is interesting, because having slab S&C kind of resolves that problem. Yeah.
And there is, slab solution for S&C sections, and PORR actually has developed its own, it's also precast slabs for S&C sections, and we've installed quite a few on different projects. I would say that this is a consideration that was made in Austria. There were a few tunnels where slab track was being installed, and there was a short section of open section in between. So, you'd have to basically transition from a tunnel into this open section, and very soon after you'd transition back into a tunnel. So especially when you have these very short sections where you would transition into ballast, like sometimes it makes more sense to actually have slab track for the entire length, because transitions are, sensitivity in the system. So this would help avoid that sensitivity. Also with switches and crossings, which are, the nature of switches and crossings is that they're a little bit more sensitive than the main line.
Yeah, definitely. So so I'm very pleased. Is this from the picture you showed earlier? So there's a picture earlier between two tunnels with a bit of with some switches and crossings. Is that section,
No,
or is it just another one?
No, this was a different section.
Fantastic. Yeah, so that's thanks for putting in a picture of some S&C for me. That's cheered me. I couldn't be happier talking about slab track until I saw this picture, and I was even happier. So here's another picture showing some for 25 kV, showing a different design of OLE mast, but that's maybe for a different show. But again, you've got the PORR slab track here, looking fantastic. On a lovely curve with the super elevation shown very nicely as well. Actually, maybe this is actually what this picture is for. Tell us a bit about how super elevation is implemented on the PORR slab track.
So as I mentioned, like the geometry is already built into the slab. So, if there is some type of a radius, like there will be there's a span of radius in the slab. This is micro radius. It cannot be seen by eye, but it can be measured by machines, and it would cover a certain, span of radius. But in case of super elevation, obviously, you also have to have that slab, where like, like there's one end of it sitting a little bit higher than the other end. And this is regulated by, if you remember the picture where this final adjustment was being done.
Ah, yeah, with the big sort of T-bar, yeah.
Yeah, so you can actually, like you can set up the slab so that it is sitting where it needs to be, with this, in this super elevation, and then pour the concrete, self-compacting concrete through these tapered openings. And then, like when concrete is cured, it's sitting in the proper position, so to say. This is because whatever the slab needs to have for that specific location, it's already designed into the slab in the factory. So the part of adjusting that super elevation and all those things is actually simple on site with this precast system. With systems which use, like concrete blocks and in situ concrete on site, Of course, adjusting that would be a little bit more complex process.
And this is something that runs throughout PORR. This is why PORR, from my perspective, PORR, and okay, systems like PORR, shall we say? Let's put I'll be nice and say other systems that are similar to PORR as well. There aren't any. Is that it's simplifying the process of installation. It's making the work on site less labor intensive, more straightforward, more repeatable, which ultimately means a more predictable program, a more reliable program, because it's much easier to resolve problems in the factory than it is to do so on site and to make change on site. So it feels like a thread that runs through everything with PORR, is that it's simplicity for installation on site. It's making sure it's as easy to install, as quick to install, as kind of minimal requirement for labor to actually install on site as possible, which is a good thing. It reduces the cost overall of the railway, frankly. Yes, so that's me getting very excited about slab track. I'll calm down and I'll go to the next pic. Was there anything else you wanted to say about this picture? Actually,
no. I think
that's good. I'm conscious of time. I'm trying to roar. We've only got a couple left. Here's another fantastic picture of a railway under construction. You can see the kind of the haul roads next to it, and you can see the track in the middle, and you can just see it disappearing off into the distance. It looks wonderful. I mean, some people would argue this is a monstrosity, but those people probably aren't railway engineers. So we have somewhat of a captive audience here, I feel. So this, tell us about this picture. I mean, this is showing it feels like there's quite a few different stages of construction going on within this just even one picture.
The image has not changed.
Oh, it's not updated yet.
Oh, I see. Yeah. I think that, since you mentioned the high-speed railway seminar with the Permanent Way Institute, what I was talking about here, with that image was that on this project in Germany, the VDE8, it was done in a way that the access roads were running parallel to the track. Of course, not for the entire length of track. There were some sections where that wasn't the case, but they really tried to build these access roads. So again, the question is of logistics. If you have those access roads, there's a lot more flexibility with logistics, and like the less complicated logistics are, the cheaper it is to build. Now you can also say, well, it takes money to build access roads, but in this case with the project in Germany, some of those access roads are, after the line went into operation, those access roads were kept, like for recreation, like it was a bike path or and in some cases, like it's actually not open for recreation, but it is access road for, the railway infrastructure owner, to access track, do their inspections, or, in case something happened, have approach. So it was philosophy for this project to build those access roads. Some of the earlier images you showed where, you had tunnel and then bridge, and then shortly after tunnel, a very mountainous section, obviously accessing track in that case is much more complicated because you have windy mountain roads, to approach the track. But in some of these areas which were a little bit more flat, it was possible to build these for construction, and the consideration was then afterwards, for recreation or for, maintenance purposes or inspection purposes.
Yeah, and it's worth pointing out for anyone who's watching this who isn't a huge fan of say, new high-speed rail construction in the UK, for the most part, HS2 is avoiding a lot of the haul roads that you see here, and are generally trying to use the track bed, keep the haul roads within the width of the track bed. Certainly through sensitive areas, through environmentally sensitive areas, you'll find that the haul road is basically just uses the width of the track bed. But that's variable depending on site conditions. So here, where this is sort of fairly flat, easy to reconstruct, and low environmental value agricultural land, it makes sense to put the haul roads in as a bit of extra, basically to build this bit really quickly, right? It's easy to do. Easier logistics mean lower costs.
Yeah, and I did mention, it's like the value there was not just during installation, it was also, the use for the local population afterwards.
Yeah.
But it really will depend, from project to project. It will depend on, like people who live in the area, on the needs,
So a railway that I harp on about all the time, which is called the Selby Diversion, which was the kind of the last. Oh, it was the first high-speed line built in the UK, and it was built in kind of the early 80s. And indeed, in quite a lot of situations, the whole road was left as like a local access road. So it's, yeah, you're right. There are lots of ways to leave, to use this. In fact, having a parallel cycleway along HS2 would have been wonderful. A lot of people would really have loved that. I think it'd be brilliant having a nice cycle path running from London to Manchester and Leeds that happens to have beautiful high-speed trains running next to it. It'd be brilliant. Anyway, the next picture is going to appear, which is, I think it's the last picture you sent, actually, which is a very arty shot of probably hundreds, if not thousands, of individually barcoded and marked up PORR precast slab units. I mean, it's a picture tells 1,000... picture kind of... What is it? 1,000 words, picture... completely forgotten the proverb. In any case, Ivana, it's a highly professional show. What can I say? Tell us about this picture. But it is brilliant. It's a very good picture.
It was just to show... This was, one of the times during peak production, where we had a lot of slabs on stock, so that we could actually provide just-in-time delivery for installation. And it really depends a little bit on how much is being built at the same time. What is the requirement? How fast should the line be built? So sometimes you have to produce slabs ahead of time. Of course, like optimally you would be producing them, installing them, soon after and not stocking up.
Yeah, because storage is cost. This is just extra project cost, right?
And it's also, it's like if you have to do this ahead of time and then you wait a while until you install it, it's like it, ideally for anyone who's doing any type of construction, you want to produce and install and be done with that.
Yeah, definitely.
But life happens, and sometimes, the situation is such that you have to actually go ahead of time and start producing, so that you would have, that you could do an installation of significant length per day, and maybe also with multiple work fronts, later down the line when installation begins.
The top tip for anyone wanting to see this scene in real life in the UK is in about, what year is this? This is 2020. In like 3 years, go and look at Calvert. Where is Calvert? Is it in Buckingham? Oh, I've no idea which county it's in. In any case, go to Calvert, and there might well be a stockpile of these at the infrastructure maintenance depot, which will be kind of doubling up as the storage site for a lot of the construction components. I don't exactly know where they're all going to be stored, and you don't have to tell us, Ivana, but that might well be one of the places where they are. And if you don't find any slab jet, there'll be other fun stuff going on. While this picture is up, we've had quite a few questions, which I think are very good questions, about carbon cost. Now, the obvious response to okay, it's carbon cost of ballasted track versus slab track. The obvious initial response is, with a reduced maintenance requirement, or indeed zero maintenance requirement, you're reducing the need for maintenance vehicles. So therefore, you're reducing the carbon cost of maintaining the railway, which is a good thing. But are there any things that PORR have done to look at reducing the embodied carbon within the slab units themselves?
Yes, I mentioned earlier that the construction width and height of our system is very low. So it's lower than any other slab track system. So, right there, if you reduce the amount, like the size or, the amount of concrete you need, you have already improved, the CO2 balance of that. And we, as far as concrete technology, this is something that our company is obviously, working on improving concrete technology and improving the CO2, and, as part of that. But I would say, one of the biggest impacts you can have is by actually reducing the amount of concrete you need, which is, which is part of the design of our system.
Absolutely, yeah. So essentially, there's a whole big picture, and you have to, just like capital costs, just like kind of euro signs. You've got to look at the kind of the overall big picture in terms of start to finish. What is the overall carbon cost of the asset, not just in the upfront, and also if it's enabling quicker railway construction, then that's also driving a reduction in carbon costs if you can get more people and things moving by rail. So wins all round. Which means the next picture up, which you will see in about 30 seconds, depending on the latency of the stream, is High Speed 2, and it's a chance for you to be very pleased about the fact that PORR are delivering slab track on High Speed 2 on the open and bridge structures for Phase 1 and Phase 2A, or is it just Phase 1? I think Phase 1 and Phase 2A are kind of bundled into one, right?
Yeah, but the Phase 2A is at this point an option, obviously, depending on the development of that phase.
Yeah. But no, congratulations on that. It's very exciting. When the news came up, it prompted me to check my email inbox and send you another email to check that, because we kept losing each other's emails in spam. But yeah, so congratulations on that, and thanks for going through that all. There's a little bit before we close off, and don't hang up when I finish. I must remember now to tell you, don't hang up when I finish, because I must say thanks afterwards. I forgot to tell you because we were playing with the tech before we started, but that's been brilliant. Thank you so much, Ivana. That's been terrific. There are lots of questions in the chat. If we haven't answered your question by the end, put it into the YouTube comments, and then I can email them over to Ivana and get an answer. As you all know, we are available on all good podcasting platforms. So thank you to all of those of you who listen in audio form. Hopefully we've audio described adequately. Support us on Discord, on Patreon rather, to make more of these happen, and go over to the Discord for the chat afterwards. And also, you can support on PayPal. The links, their links are all on YouTube, and I've said them a million times. I'm not going to say them again. Next week is episode 40. Good grief, the 41st episode of Rail Natter. We're going to talk about 4 crashes that improved Permanent Way for good. Kind of, we learn from our mistakes. We're going to talk about 4 UK or British railway accidents, derailments that we very much learned from as an industry. So that hopefully should be quite interesting for all of you. And it only really remains to say, Ivana, that's been brilliant. Thank you so much. We've gone very long. I'm so sorry for taking up so much of your evening. Hopefully
it was a pleasure.
Yeah, I'm sorry the video wasn't working as well. So you've in a way, it's a blessing, because you've been able to avoid looking at me sort of. In fact, you've avoided looking at me kind of dancing around, except you've seen it on YouTube. So actually, you have seen me kind of dancing around manically. Thank you to Dr. David Turner for sending me some nice beer, by the way, which I've been drinking this evening. Ansbach and Hobday, highly recommended. I don't know, you didn't have a chance to drink any wine, Ivana. I was wondering if you would be getting involved in having a tipple this evening. But just some water.
I have a glass of wonderful fresh water.
The responsible choice. The responsible choice. Everyone who's been joining us in the chat, thank you so much. Come over to the Discord for a bit more. Lots of thanks to you, Ivana, in the chat as well. Ivana, it's been a pleasure, and maybe we'll have, once High Speed 2 starts working, maybe we'll go and we'll have a follow-up chat and sort of can see how things are going, and yeah, fingers crossed. It's only the start. We're going to see a growth of slab track across the UK and beyond. In any case, cheerio, everyone. Thanks very much, Ivana. Cheerio.
Thank you. Bye.
Thank you. Bye.